Hello, hello. It is Monday, December 6th, and I am going to take on day 6 of the Advent of Code. Um, Seems to be working. Okay, good. So let us check out day 6. Seafloor is getting steeper. Maybe this lake he's got carried this way. A massive school of glowing lanternfish must pass. They must spawn quickly, maybe exponentially quickly. Should model the growth rate to be sure. Although you know nothing about the specific species of lanternfish, make some guesses. Surely each lanternfish creates a new lanternfish once every 7 days. However, this process isn't necessarily synchronous between lanternfish. One lanternfish might have 2 days left until it creates another lanternfish, while another might have 4. So you model each fish as a single number that represents the number of days until it creates a new lanternfish. Furthermore, you reason a new lanternfish would surely need slightly longer before it's capable of producing more lanternfish. 2 more days for its first cycle. So suppose you have a lanternfish with an internal timer value of 3. After 1 day, its internal timer will become 2, 1, 0. After another day, it would reset to 6, and it create a new lanternfish, internal timer of 8. Okay? The lanternfish that creates a new fish resets its timer to 6. The new lanternfish starts with an internal timer of 8 and does not start counting down until the next day. Realizing what you're trying to do, the submarine automatically produces a list of the ages of several hundred nearby lanternfish. For instance, suppose you're given the following list. This list means that the first fish has an internal timer of 3, the second fish has an internal timer of 4, and so on until the fifth fish, which has an internal timer of 2. Simulating these fish over several days would proceed as follows. Initial state, 3 for this, after 1 day, and so on and so forth. Each day a 0 becomes a 6 and adds a new 8 to the end of the list, while every other number decreases by 1 if it was present at the start of the day. In this example, after 18 days, there would be a total of 26 fish. After 80 days, there would be a total of 5394. Find a way to simulate lanternfish. How many lanternfish would there be after 80 days? Okay, good. So here's what we... Uh-oh, I don't know what happened. Here's what we want to do. Because I don't want to model a lanternfish as an object, because exponential growth, I'm just going to need a lot of objects, right? But what occurs to me is that the only thing I really need to know is how many lanternfish are there with each count, right? So, and each day I roll them forward, and every time, and I roll the zeros to be 8s and 6s, right? If that makes sense. It'll make sense once I start doing it. Day 06.py. Okay. This is probably overkill to do it like this. In fact, it's definitely overkill. Well, I'll do it. Input equals. Okay, good. That's good. And now let me make sure after 80 days. Okay, so what I want to do is I want to say I'll still do class lantern fish and def init self and what are these things called? They're called timers, which is a list of ints. And from typing import lists, that's good. Okay, and so what I want to do is I want to say self.timers equals, and I want to be a dictionary, and I want it to be I to 0 for I in range, I think 9 was what I wanted, right? So you know, start 2 more days. With an internal timer of 8 and is not starting down. Okay. Okay, and then for timer and timers, self.timers timer plus equals 1. That's right. Okay. So I've done that. And now all I need to do is I want to self to none. And what I want to do is the following. New timers equals let's say I minus 1 count for I count in self.timers.items. So that seems right. So basically I want to move everything to the lower if I is bigger than 0, right? Because, and then new timers 8 equals self.timers.0, and new timers 6 also equals self.timers0, and then self.timers equals new timers. Okay, right? So what I'm doing is I'm doing the following. I'm saying for each I count, I want to move them down one, right? So what was 1 goes to 0, what was 8 goes to 7, and so on. And then whatever was at 0, I want to put it in 8 and 6. And so it occurs to me that it's stupid to use a dict for this. I'm going to change it to a list of int equals 0 for I in range 9. Okay, so that's fine. And new timers equals, so now what I can do is I can just slice it, right? Self.timers 1 plus 0. Okay, new timers 8, self.timers. And now if they change the timings, that will screw me up, but I think that's right. And this is cleaner with, okay, and so let's say LF equals lanternfish input for in range 80 LF.step and lantern def, and I want to count the fish as well. Good. And so I'll just return the sum, right? So if there's 1 at 0, 2 at 0, and so on. And then what I want to do is after 18 days, there are a total of 26 fish. So let me insert both of these. Assert lf.count equals, what did I say it was? 26. And then for n in range 80 minus 18, which is what's left, lf.step. And now I want to assert that lf.count equals 5934. Okay, so let's run that. See if it passes. Assertion error. Okay, good. So let me do this. Print self.timers and see what went wrong. Okay, so something I screwed up. It could just be an off by 1 error. So I got 3 4 3 1 2. So that's 1 2 3 3 4. So that's right. Then after 2 days, it's 0 1 2 2 3. That's right. Then after 2 days, it's there's a 0, there's 2 1s, there's a 2, no 3, 4, 5, 6, and 8. So this looks right. And then after 18 days, there are a total of 26 fish. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17. Okay, so there's definitely initial state. Let's see what I did wrong, because this looks right. Actually, no, it doesn't look right, because I'm not getting enough fish. So 1, 1, 2, 1. Because there should be a lot more fish that I'm not seeing. So what am I doing wrong here? After 4 days is 2 8s. Then there's 1 8 and 2 7s. Then 0 0 0 0 0. And then at some point there's so something's not 6 6 6. So after 4 days there should be a bunch of 6s. So why is that? I know why. New timer is 8, because I'm overwriting both of these, and so I need to be adding to them because there's already something in position 6. So let us try that again. I think that was my mistake. Okay, good. So now my test passes. I can get rid of that print statement. And now let us go and get my puzzle input. And let us Copilot's not doing a lot for me today, but that's okay. I'll do it myself. Okay, and so now let's say raw equals open data/data6.text. I was smart of it to call it that. And input equals int x. That seems right. LF equals lanternfish input, and let's make sure that it's 80 steps again. Yeah. For blank and range 80, lf.step, print lf.count, so that seems right as well. So now let's run this and see what it prints. Prints 386,000. So yeah, if I tried to track them, I'd get 386,000 inputs, and that's not right. Or that's not a great thing to do. So as lanternfish live forever and have unlimited food and space, would they take over the entire ocean? After 256 days in the example, there would be a total of this many lanternfish. Okay, 256. So this is where they would get you if you had modeled each one as its own object, right? So luckily we didn't do that. So let's go here and say for n in range 256 minus 80. Yep. And then assert that lf.count equals this. What did I say? 256, is that right? Let me check that. Yeah. Okay, so let's run that test and see if it passes. It does. Okay, and so now let us go here and say, again, for blank and range. Hey, it knows 256, that's good. Minus 80, lf.step, and then print lf.count, so that's good. And now if I do that, it is a large number. Obviously, I don't want to simulate this many objects. That would be more memory than my poor little laptop has. So that is the right answer. Okay, good. So the key here was really in guessing that they were going to guessing that modeling each fish as an object was a bad idea, because they're going to ask us to model too many fish. And I've done Livecoding enough times that I'm good at guessing that sort of thing. And so then it becomes a question of how can I model this in a way that doesn't require me to model every fish? Well, all I care about is how many fish are at each stage at any point in time. There's only 9 stages, I guess, since it's 0 indexed. And so that means that with, just an array of 9 items, I can keep track of that, right? So I just put zeros, I count my timers, and then each time I just follow the logic and slice, add a 0, increment both 6 and 8, and then update. So it's relatively simple. I mean, you saw that I made a stupid mistake where I clobbered 6 instead of adding to 6, which was bad. But we caught it and we fixed it, and yeah, it worked. All right, cool. So that wasn't too bad, and I will see you tomorrow.